Hi everyone, welcome to week 9 of our SHSAT trading program. So this week's math topic is going to be solving systems of equations using the substitution method. So first of all, we have to define what a system of equations is. It's basically a collection of multiple equations that use the same variables that you can solve using one another, so you can solve them simultaneously. For example, this is a system of equations. 2x plus y equals 7 and x plus y equals 5. Although neither one of these equations by themselves are solvable for specific values of x and y. If you think about like the second one, for example, x plus y equals 5. There are a lot of values of x and y that satisfy this. There's actually an infinite amount. But since we have two equations that use the same variables, we can use them to solve one another. And in this case, I think x would be 2 and y would be 3. So generally, this is important. A system of equations is only solvable if you have at least as many variables as you have equations. So for example, if you have 3 variables, but only 2 equations describing them, then you can't solve for specific values of those variables because there would be multiple amounts. For example, here, we have 2 variables and 2 equations, so it's solvable. If we had 2 variables in one equation, like for example, just 2x plus y equals 7, that would not be a solvable equation. And the substitution method is basically a method for solving systems of equations in which you take one of the variables and you sort of rewrite it as a combination of the others. So then you have less variables, and then you sort of reduce the system of equations until it just becomes a one variable equation. And then you solve for one of the variables and then you sort of build back up. Like in this case, substitution would be, okay, if I took this second equation and I wrote, okay, x plus y equals 5, that means x equals 5 minus y. And then I was like, okay, now I know x equals 5 minus y. So then I took this second equation and I was like, 2x plus y equals 7. Okay, what I'm actually going to do is, since I know x is 5 minus y, I'm going to say 2 times 5 minus y plus y equals 7. And that's just a normal equation. That's a one variable equation, which we know how to solve. This is 10 minus 2y plus y equals 7. So 10 minus y equals 7. Then I can recombine. So I know y equals 3. So then I've solved for one of my variables. Now I need to go back and find what the other one is. So I have x equals 5 minus y, and I know y equals 3. So x equals 5 minus 3. X equals 2. So that would be the solution to that system of equations, and that would be the method for solving it using substitution. So we're going to do some practice problems. So the first 2 practice problems are just practice with the substitution method, so like if you notice, for example, number 112, this is 2 variables, but we only have one equation. So we can't solve for specific values of x and y. But what we can do is we can substitute and essentially find x in terms of y. So that's, the substitution part. And then if we had more information, we would go ahead and solve for x and y, which we can't do. But anyway, the problem is, if 4x minus 3y equals 12, what is x in terms of y? So we have 4x minus 3y equals 12, and we need to get x by itself. So this becomes, if we add 3y to both sides, this becomes 4x equals 12 plus 3y. Now, since we have 4x, we're going to just go ahead and divide by 4 since we want x by itself. So you get x equals 12 over 4 plus 3y over 4, or x equals 3 plus 3/4 y. So if we look, x equals 3/4 y plus 3, that's answer choice G. So that's going to be what x in terms of y is, and that's going to be the answer to number 112. So similarly, we can also do this for equations that aren't linear. In other words, like for equations where we're not just adding the variables, we're also multiplying them. So in the equation above, w, x, y, and z are positive numbers. Which of these is equal to z? So again, notice we have 4 variables here and only one equation. So obviously we can't really solve for the variables, but we can isolate them and find the variables in terms of one another. So here we have w over x equals y over z. Well, notice since w, x, y, and z are all positive, neither w over x nor y over z are going to be equal to 0. So we can actually divide by both of those things. So what we're going to do is we're going to take 1 divided by w over x And we know that since wx is equal to y over z, this should be actually equal to 1 over y over z, because we're taking 1 and we're dividing it by the same value. So obviously we're going to get the same value out of it. So 1 over w minus 1 over w over x. Sorry, that's just going to be x over w. And 1 over y over z is just going to be z over y. So here we're almost there. We just need to get z by itself. So what we're going to do is we're going to multiply by y on both sides. So we're going to get xy over w equals z. So z equals xy over w. So that's answer choice H. And that's going to be the answer for number 100. So that's sort of practice. And that's the method for how you would do the substitution part. But of course, the topic of this week is solving systems of equations using substitution, not just doing substitution on systems of equations. So now we're going to look at two examples where we actually do have enough information to solve the systems. So 87. Today, Tian's age is a quarter of Jordan's age. In 2 years, Tian's age will be a third of Jordan's age. How old is Jordan today? So first, we need to actually build the system. So we're going to have two variables here. We're going to say, okay, let t equal Tian's age. And let j equal Jordan's age. So we know that Tian's age is a quarter of Jordan's age. So in other words, t equals 1/4 j. And in 2 years, Tian's age will be a third of Jordan's age. Okay, well, in 2 years, how old is Tian going to be? He's going to be t plus 2 years old equals a third of Jordan's age in 2 years. Well, in 2 years, Jordan's going to be j plus 2 years old. So this is our system of equations. Now we need to go ahead and solve it. So if you notice, this is actually really nice because they already gave us our substitution. We don't have to do anything to get one of the variables just in terms of the other, because we already know that t equals 1/4 j. This is our substitution because it already gives us one of the variables just in terms of the other. So now we're going to look ahead at the second equation in our system of equations, and we're going to replace t with 1/4 j. So we get 1/4 j plus 2 equals, and then we're going to go ahead and we're going to expand. So 1/3 j plus 2/3. Okay, so now we're going to have to solve for j here, right? So we get, if we subtract 2/3 and we subtract 1/4 j, we get, what do we get? We get, so on the left side, the 1/4 j cancels out. 2 minus 2/3 is 4/3 equals, and on the right side, the 2/3 cancels out, and 1/3 j minus 1/4 j, well, that's just going to be 1/12 j, because it becomes 4/12 j minus 3/12 j. So 4/3 equals 1/12 j. So if we multiply both sides by 12, we get 16 equals j. Okay, so now we know that j is 16. In other words, right now, Jordan is 16 years old. Now we need to figure out so that's all we need to find, really. The question is, how old is Jordan today? That's what j is, and we just found j. We know j is 16, so currently Jordan is 16 years old. That's answer choice D. Now we're going to do one more problem. The sum of the numbers x, y, and z is 50. The ratio of x to y is 1 to 4, and the ratio of y to z is 4 to 5. What is the value of y? So notice here that this is actually a 3-variable system of equations. We have 3 variables. Those are x, y, and z. However, that's okay because they actually gave us 3 pieces of information about those variables, so we can still go ahead and solve. So the first thing they give us is that the sum of x, y, and z is 50. So in other words, x plus y plus z equals 50. The second thing they give us is x to y is 1 to 4. What that means is x over y is 1 over 4. And the last thing they give us is y to z is 4 to 5. In other words, y over z equals 4 over 5. So to solve this using substitution, we need to actually get both 2 variables, both in terms of the other ones. So the easiest way to do that here is going to be to get everything in terms of y, because we already have an equation that relates x and y That's this one, x over y equals 1/4. And we have an equation that relates y and z, which is y over z equals 4/5. So all we need to do now is get both x and z in terms of y, and then plug into our first equation, which is that x plus y plus z equals 50. So here x over y equals 1/4. So what we're going to do is we're going to multiply both sides by y to get x by itself. So x equals 1/4 y. This is x in terms of y. And then we're going to do something similar for the second equation, which is y over z equals 4/5. We're going to multiply both sides by z and 5. So we're going to multiply both sides by 5z. So we're going to get 5y equals 4z. And then we're going to divide both sides by 4 because we want z in terms of y, right? So, so we get 5/4 y equals z. Okay, so now we have x equals 1/4 y and z equals 5/4 y. And we also know that x plus y plus z equals 50, right? So what we're going to do now is we're going to plug in our values for x and z that we just found. So we know that 1/4 y plus 5/4 y equals 50. Okay, and this is just a one variable equation. So this 1/4 plus 1 plus 5/4 is going to be 10/4. So we know that 10/4 y equals 50. And to solve for y, we're going to multiply by 4/10. 50 times 4/10 is going to be 20. So we get y equals 20. And the question was asking us what the value of y is. And that's what we just found. So we just found that y is 20. So the answer is going to be h. So yeah, that's about it for substitution. Next week, we're going to upload a math video which highlights a different method for solving systems of equations, since it's a very important skill and it shows up in a lot of different problems and a lot of different contexts. So if you have any questions about substitution, as always, feel free to ask in the comments, and otherwise we'll see you next week.